assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
So in this example, we're given a motor, which I've drawn a little abstraction of on the left here, where on the left side we have some voltage source, and on the right-hand side we have our motor with some internal resistance and a magnetic field that causes a back EMF. So what we want to figure out is, given these knowns about the voltage, the current drawn, and the resistance of the motor, we first want to find the back EMF generated by the motor. After that, we're going to look into finding the current when the motor first starts, so that there isn't enough time for a back EMF to actually interrupt or interfere with us. And then we're going to figure out what kind of resistor we would have to add in order to limit our current to a certain amount. So starting with part A, let's look at the back EMF. So from Ohm's law, we know that V equals IR, right? And if we have an effective voltage over here in our motor from the sum of the voltage we supply and the back EMF, this will instead look like this. V minus the induced EMF equals IR. So a common way we'll see this stated is that the current that ends up getting drawn is equal to V minus the back EMF divided by R. So we can go ahead and solve this for the back EMF, right? Let's just take this version here and add E to both sides and subtract IR from both sides. And we should have that the EMF is equal to V minus I times R. So if we plug in our values over here, where V is 120 volts, I is 7 amps, and the resistance is 0.72 ohms, we will get that the back EMF, when this thing is in full swing, is equal to 115 volts. Okay, now a different question. Let's say we've just turned on our motor here. So it hasn't had time to really get moving at all. And the thing we need to realize is that the movement is actually what's going to cause our back EMF in our motor. So when our coil in our motor starts spinning, right, it's going to be a conducting loop in a magnetic field. And that motion is going to change the flux in that loop. And that's going to, in turn, introduce a back EMF. So when the motor first just starts, we actually won't have any back EMF at all. So that equation we had over here for the current is equal to V minus E over R will just end up being Ohm's law because there's no back EMF yet. And if that's the case, all we have to do is plug in our voltage and our resistance here to see that the current at the beginning, which we'll mark with a B, is going to be 167 amps. So the current at the start is 167 amps. So of course that's going to go down by a lot. We know that eventually, once this thing gets stable, that the current is 7 amps. So this is a huge spike at the start when this thing first starts spinning. So now we're going to try to mitigate this spike from happening, and we're going to ask ourselves, what resistor, with resistance R prime we'll call it, do we have to put in series with the resistor in our motor in order to keep this spike here limited to 15 amps? So we want I at the beginning to be 15 amps. Okay, Well, let's go modify our drawing first. I'm going to add in a little resistor here in series with our other one, just so we know what we're dealing with. So we have R prime now in addition to R. So really what we're going to be dealing with in Ohm's law now is the net resistance of our whole circuit here, which for resistors that are in series is just going to be the sum of their resistances. So again, let's just write down Ohm's law. V equals IR, where now our R is going to be R plus R prime. So this is R total right here. Okay. So what we wanted to know is what the value of R prime needs to be. So we're going to solve for that. So we'll divide both sides by I. We'll have V over I equals R plus R prime. And then we'll subtract both sides by R. So we should have R prime equals V over I minus R. And now we're in a situation where, again, we can just plug in all of our values. And remember, this I is specifically the I at the beginning of when our loop first starts spinning. So if we do that and we plug all of those values in, we'll get that the resistance of our added resistor in series needs to be 7.28 ohms.